In today's lesson, we will be making predictions from a sample. Our learning target says, I can use the data from a valid or unbiased sample to make a prediction for the entire population. All right, let's start with this first example. It says the local pizzeria estimates that 72% of their customers order pepperoni on their pizza. Out of 250 orders taken in one day, how many would you predict to have pepperoni? Well, if we think back to what we've learned this year, there's actually two ways we could solve this. We could use a proportion, or we could use the percentage. Blank percent of this much is this much. So let's try it both ways. So in our proportion, our percent always went over 100. So 72 out of 100 people ordered pepperoni on their pizza. So this is the part over the total amount. So that just means I have to place the 250. The 250 are the total orders taken in one day. So that belongs down here. So what you would do, we don't know this number, you would take 72 times 250, so go ahead and get a calculator, take 72 times 250, and then whatever you have left over, you're going to divide by 100. And it looks like we have 180 customers. Out of the 250, we think we'll be ordering pepperoni. So let's see about this other method, because a little later in the year we talked about percentages, and we had 72%. We predict 72% of the 250 orders would be how much? So in this case, you're going to take your 72 and use your percent key. Of means to multiply, so hit multiplication, 250, and if you enter, you still get. We think that out of 250 customers, 180 of them are going to want pepperoni pizzas. It doesn't matter to me if you use one of these methods or a different method, as long as you're getting the right answer and, of course, showing your work. All right, this one says a bag contains 9 red chips, 4 blue chips, and 7 yellow chips. You pick a chip from the bag, record its color, put the chip back in the bag. If you do this 100 times, how many times do you expect to remove a yellow chip from the bag? So on this one, there is no percentage. So I might set up a proportion for this. I know that I'm looking for the yellow chips. And it tells me that right here I have 7 yellow chips. 7 yellow. But remember, my top number is my part. I need to know how many are in all. So if there were 9 red and 4 blue and 7 yellow, you would pick up your calculator and add those all up, and you would get 20, I believe. So 7 out of the 20 total chips are going to be yellow. I have one other number to deal with, this 100. That tells me how many total times I'm going to do this experiment. My total goes on the bottom, 100 total times, and I want to know how many will be yellow. So I would pick up my calculator, and I would take 7 times 100, and you're doing this with me, divided by 20, and it looks like I would expect, or I would predict based on this sample, that there would be 35 yellow chips pulled in 100 of these experiments. All right, I want you to try this one without me. Remember, you have two options. You can go way back and do proportions, or you can do percentages, or you could pick some other method, but I want you to show your work. See if you can come up with the answer to this question. A store claims 78% of shoppers end up buying something. Out of 450 shoppers, how many would you predict will buy something? Pause me while you work this out, and then come back for checking. Okay, I'm going to do this both ways. I'm going to have a proportion. We have the part on top and the total amount on the bottom. So 78% means you have 78 out of 100 people end up buying something. And we have a total of 450 customers. So that goes on the bottom, and I don't know that answer. So you would pick up your calculator. 78 times 450 divided by 100. We could predict that 351 customers, actually I'm going to call them shoppers, sorry. Shoppers will buy something. If you use the percentage method, you had 78% of the 450 shoppers would equal how many people? Put 78 and your percent sign. Of means you're multiplying by 450. And again, you're going to get 351 shoppers. Now, it's important to note right here that these surveys have to be valid. They have to be unbiased. If you are making predictions from a bad survey, you're going to get a bad prediction. So make sure always that you have a good survey. And the ones that I'm giving you today, they're all good surveys. Time to set up your paper for your video questions. So make sure you have your first and last name, the date, and your period. On the left, you're going to write your answers, and on the right, you're going to do your work. It can be any method you want, proportions, percent key, some other method, but you have to show work or I'm not going to give you credit. All right, question number 1 says, a survey showed that about 40% of American households own at least one dog. Based on that survey, how many households in a community of 800 households own at least one dog? Pause while you're working this out. Come back when you're ready for question 2. Video question number 2 says, a quality control inspector has determined that 3% of the items he checks are defective. If the company he works for produces 3,000 items per day, how many does the inspector predict will be defective? Show your work, calculate your answer, come back when you're ready for question number 3. Question number 3 says, a survey showed that 78% of students who take a bus to school carry a backpack. Predict how many of the 654 students who take a bus also carry a backpack. Pause me while you're showing your work and calculating your answer, and come back when you're ready for the next question. Video question number 4 says, a survey shows that 43% of high school and middle school students buy lunches at school. If a school district has 2,900 middle and high school students, about how many would you expect to buy school lunches? Pause while you're showing your work and calculating your answer. Come back when you're ready for the last question. Video question number 5 says, if you roll a number cube 30 times, how many times do you expect to roll a number greater than 2? When you are all done showing your work and calculating your answer, hold on to your paper until tomorrow. It is due at the beginning of class.